Hello and welcome. In this experiment, we explore how a basic industrial automation system works, combining a level sensor, a PLC, and a SCADA system. Together, these components controls a discharge pump based on the fluid level inside a reservoir tank. We'll show you how we trace the system from schematic drawings to the actual plant, and how the entire process works.
Now, let's look from P&ID diagram to trace the line.
First, we begin with line tracing using the P&ID or process and instrumentation diagram. The diagram shows the key components like the reservoir tank, tuning fork level sensor, discharge pump, and the PLC connection. Here, we can clearly trace the signal path from the sensor to the PLC and from the PLC to the pump. Understanding this layout is important before moving to real work tracing. As you can see in the video, we are now tracing the line using P&ID from tank 203 to tank 209. We can see a lot of static and rotating equipment that is involved in this system. Next, we trace the system using the SCADA interface. First, we are turn on the MCCB. Then, we are turn on the power switch. Then, we are test the voltage. And lastly, make sure PLC circuit breaker is turned on. SCADA stands for Supervisory Control and Data Acquisition. It allows us to visualize and control the process in real time. As we can see in the video, we are using SCADA system to trace out the line that is involved between tank 203 and tank 209. As of right now, we can see that tank 209 is empty. Here, you can see the level sensor status and whether the pump is active or not. The SCADA also can provide historical, trend and alarm to help us monitor performance and safety.
Now, let's trace the line at the plant. Make sure we are fully equipped with proper PPE, which is helmet, glove, coverall, and safety shoe. With the diagram and SCADA as our guide, we move to the plant for physical line tracing.
Here's how the system works. When the water level in the tank is below the tuning fork sensor, the fork vibrates freely. This sends a low level signal to the PLC and the pump stays off.
Control room to plant, please verify the pump 219 movement.
Plant to control room, pump 219 is turned on.
As we can see in the video, the fluid from tank 203 is now entering tank 209. Now we can take a dipping stick to measure the volume inside tank 209.
Control room to plant, please verify if the pump 219 is already turned off or not.
Plant to control room, pump 219 has no movement.
As the water level rises and touches the fork, vibration stops. The sensor detects this and sends a high level signal to the PLC. If the pump is turned on, the fluid will flow into this pipe section and enter this oil filter. The fluid will then come out cleanly and will enter another valve and will flow into tank 203. On this location, please make sure that the valve is open correctly, since there is so many valves that can enter into many sections. As we can see, this is the final product.
Okay, so we have developed our own sketch of the fluid transfer system involving the level alarm high and level alarm low, and also the PLC system that is connecting to pump 219. Okay, so let's look. First, there is tank 203 connecting with pipeline and connected to pump 203. And it will go to heat exchanger and finally go into tank 209. So, in this fluid transfer system, we have two level alarm, which is level alarm high and level alarm low. And these two gives feedback to PLC system. For example, if there is water touching the tuning of level alarm high, and this level alarm height will connecting to artificial input inside the PLC system. It will then give feedback to artificial output, and this artificial output of PLC will give another feedback to pump 219, and it will say, hey, there is water that is touching upper side of this tank, so it will want the pump to on. Now let's look over level alarm low. So if the water is already empty inside tank 209 and level alarm low doesn't touch the water, and it will vibrate and give a signal to PLC system. It will tell artificial input and give feedback into artificial output, and then give another feedback to pump 219. The pump 219 will connecting to PLC system, like PLC system will say that, hey, this pump is already empty, so pump 219 needs to be closed and shut down immediately. This whole system is called closed loop system, and this is because the constant feedback that is reaches the level alarm high and level alarm low and PLC and also the pump, and and this whole system can be controlled automatically and manually from level alarm high, level alarm low into PLC system, and finally pump 219. The pump will connecting into vessel 203. And I forgot to mention that this whole system is controlled by SCADA system inside control room.
Through the experiment, we have learned how fluid level control systems are automated using sensors, PLC, and SCADA. We saw the system from design to simulation and to actual field implementation. This hands-on experience gives us deeper insight into how control systems function in real industry settings. That's all from us. Thanks for watching.